Hello. Now I'm going to show my demo of time series analysis univariate with exogenous variables. Part 1 using pycaret. So as we know, pycaret is a low-code AutoML library used for automating ML workflows. So starting with the installation, you have pip install pycaret. It installs the complete pycaret dependencies, and we have some other dependencies as well, and plot settings. Coming to the data, I used pycaret's air quality data, and we created a new column index by combining the date and time columns and converting them into a date time format. The original, after that, we removed the date and time columns, and next, the target variable for the forecast is CO. Let me check that. COGT. We replace any values in the data set that is equal to minus 200 with NaN, not a number, for better handling of it. We import TS forecasting experiment class and assign it to an object so that we can able to set up a setup session with exp.setup, which takes data, target, index, and other metrics as well. And we can see it returns some metrics about the data and the pre-processing stuff. And next, plotting the target variable. Uh, the first time series plot visualizes the target variable COGT with other variables. The data, as the data set is very large, the PNG static renderer is used to speed up rendering. So after plotting with resampling, we use it with we use plotting with resampling. We use plotly dash format with a resampling mechanism that reduces the number of shown data points, making the visualization, a bit fast. And then differentiating the data, we apply differentiating for use by using a first order difference. This makes the data stationary by removing trends. ACF, PACF, and periodogram plots are also generated for better visualization. Uh, we can customize differences uh, for both first orders and seasonal ones as well. Seasonal in the sense which has a lag of 24 hours or a day. And coming to CCF, cross relation functions. Finally, finally we plot the cross correlation function to check relationship between target and exogenous variables. This helps in identifying which other exogenous variables, external variables, might impact the target as well. And we actually skip the variables like LMHC, GT, and AH because they are not that required. And coming to the part 2, the same installing pycaret and other dependencies, setting the plot settings, getting the air quality data, and doing the same pre-processing as before. Now the forecasting setup. We set up a univariate forecasting experiment using the provided class TS forecasting experiment. The forecasting horizon is set to 48 steps, and that a forward filling is used to handle the null missing values, and we can see it returns some metrics about it. Now we're going to create and plot a ARIMA model. For the univariate data, we create a ARIMA model with the required parameters and order 010, seasonal order 01024. How well and to see how well the model fits the data. Multivariate forecasting setup, and we now move to multivariate setup where we include other variables along COGT. The same model we use here as well, and the results are plotted. And now we predict once among these two the best model is selected, we use it for future analysis. We define a function like this called predict vapor to generate predictions and catch any exception errors during the prediction process. Errors in the sense like if you miss any exogenous variables, then we can handle them. Now, uh, we in next one we created a slimmed down version of the data set. I mean, not only a few variables, we set up the experiment again, and we again apply the same ARIMA model as well. And we can see some of the metrics, root mean square error, MAP, R square, etc. and its plots. Now we finalize the model and save it using the save model function. Now we now focus on modeling the future values of these variables, of these exogenous variables, NO, XGT, uh, PT8, S3, NOx, RH. For each exogenous variable, forecasting experiment is set up, and we can select the best model from that. And now we can see now we combine the future predictions for each exogenous variable into a single data frame for maybe a future use. Uh, Finally, what we do is we load the previously used the slimmed down model and predict future values using the exogenous variable forecast. So the predicted results are then we can plot it, and we can see the results plot. And coming to the third part, uh, the same installation of pycaret and other dependencies with plot settings as well, defining plot settings as well, the same data set and the same pre-processing. Now we define we set up a forecasting experiment using the setup function, the data targets, and forecasting horizon 48. And this setup is configured for handling both univariate and multivariate data. After the setup, we can see some of the metrics it generated. I mean, the insights about the data. Now we use compare models function. Basically, it trains it trains all the available estimators based on the data and returns the best one. Also, it sorts based on the metric we define. The best model usually is selected on the base of MAC metric. After it, we plot to see the actual data versus its prediction interval versus its forecast of ARIMA. So we finalize the model using the finalize model function and then uh, generate plots. Now for handling exogenous variables, we define a function called predict with fallback. Suppose if the selected model, if it needs exogenous variables, the function generates predictions for those variables, future predictions. These forecasts are then used input. These forecasts are then used as input for final models future predictions, and then we generate future predictions using the final model with the predict with fallback with function with the predict with fallback function with the defined parameters. If exogenous variables are needed, what we'll do is we first forecast them, and then the predictions will be we will plot the predictions for analysis. So this is my demo of time series univariate with exogenous variables. Thank you.